Okay, we're going to talk a little bit more about proportions. And in this lesson, we're actually going to prove for a second why cross multiplication works. Okay, so there are several rules that we use when we're solving a proportion, but we may or may not even realize that we're using it. So for example, we know that if A over B equals C over D, this is a proportion, and we know that we can cross multiply, and that that will help us solve for any of these variables. So what would that look like? So, well, then if we cross multiply, then we know that A times D equals B times C. Okay? And similarly, I can solve this by just, once again, rearranging. I'm going to divide this side by A. I'm going to divide this side by C. And what we would then get is B over A equals D over C. So this is not anything new or different. This equation is not anything new or different. All it is this original proportion rearranged. All three of these, this, and this are the exact same thing. They're just different versions of the same proportion, right? Because we haven't changed the equality of it. Why am I showing you this? Well, because this tells us, these different rules tell us about proportions. Once again, this right here is just another version of the exact same proportion. We could keep going on, right? That all of these rules are all true. They all make sense. I could solve for each of these from this original proportion. And if all of those things are equal, then these are rules that we can actually use to learn about different types of proportions. Here's what I mean. In the diagram, A over B equals B over D, and A over C, AC over CE. AB over BD equals AC over CE. Find the length of BD. Well, here is where we're going to see where some of our rules might make some sense. Look at the picture, and I want you to understand what this means. AB over BD, that relationship, the relationship between those two segments, is going to be the same as the relationship between AC and CE. That should make sense to you, even just by looking at this figure. So if we actually were to use these values now, this is 16, AE is 30, and CE is 10. Let's try and set up this original proportion. I'm going to do this over here. So AB over BD, that's 16 over, we don't know what BD is, so I'm just going to leave it there, over BD, equals AC. Do we know what AC is? We're not originally given it, but if we know that this whole side is 30 and this little CE section of it is 10, then AC would have to be 20. So we know AC is 20, and then we're obviously given that CE is 10. This is a proportion that I can obviously solve. Okay, so let's do that. 16 times 10 equals 20 times BD. And 160 equals 20 BD. So I need to divide both sides by 20. And if I divide both sides by 20, then we get that BD is 8. Let's go back and look at this original proportion and make sure this makes sense. What this proportion is saying is that the relationship between 20 and 10 has to be the same relationship between AB and BD. So 10 is half of 20. So if AB is 16, then BD should be half of that. Did we get that? Yes, we got that BD is 8, which is exactly half of 16, so that works. Let's move to another example. in this diagram, AB over BD is the same as AC over CE, so same proportion. But now we're given slightly different information. We're given AD, that whole side is 16. We're given that AC is 10. And we're given that CE is 8. Now, can we write this proportion? Well, we know what AD is, but we don't know what AB and BD is. So how are we going to set this proportion up? Well, we're going to have to do some work. Let's say that I call BD X. Okay, since I don't know it, I can call it whatever variable I want. Why does that help me? Well, because I might can use that to write this proportion and then solve. So AB, if this is X and this whole side AD is 16, then AB would have to be 16 minus X. Here's what I'm saying. If the whole side AD is 16 and this little section is X, then if I take that whole side and I subtract out this little section, what will be left is that. So even though I don't know what AB is, I can represent it by 16 minus X. So if I can represent it by 16 minus X, then I can write this proportion and maybe solve. So if AB is 16 minus X, and that over BD, which we're representing as X, equals AC, which is 10, over CE, which is 8. This is a proportion that we can now solve. Let's cross multiply. And what we would get, and I'm going to come down here and do this, is 8 times 16 minus X equals 10 times X. So I'm just going to write 10X. I need to distribute this. 8 times 16. Let me pull out my calculator. 8 times 16 is 128. So 128 minus 8x equals 10x. Now I need to collect like terms, so I'm going to add 8 to both sides to get this over here. And what we would have is 128 equals 18x. So in order to find x, I need to divide both sides by 18. So I need to divide 128 by 18, and I get that x is 7.1. Repeating. Did I do that right? Let me just double check real quick. Yeah. Okay, very good. So in this case, using a little bit of some kind of trickery helped me solve this problem. And it really wasn't trickery. It was just kind of a smart tactic that we can take to represent multiple sides of a figure. And now we need to find the length of BD. Well, this is the length of BD right there, x. So sometimes just calling something x and then using this trick of calling whatever's left of that side of the shape 16 or the whole length minus that can help us solve. So let's continue right along. Last slide really quickly. Geometric mean. The geometric mean of two positive numbers a and b is the positive number x such that a over x equals x over b. So a geometric mean is the special position in a proportion where we have a and b, and in a proportion that x value goes both here and here in that proportion. It occupies both of these spots in this proportion. Okay? So if I were asked to find the geometric mean of 4 and 9, I'm trying to find the geometric mean of a and b. So I would need to set up this exact proportion. And it's asking me to find the geometric mean. So x is the geometric mean here. I'm trying to find the geometric mean of 4 and 9. So I need to replace 4 and 9 with a and b in this proportion, and then solve. And if I cross multiply this, I get x times x is x squared. 4 times 9 is 36. So I need to take the square root of both sides, and I get that x is 6. X is the geometric mean of 4 and 9. It's the average by multiplication of 4 and 9. We all know what an arithmetic mean is. An arithmetic mean is I would add them together, divide by 2. That's an average, right? But a geometric mean is still an average. It's still a mean, but it's just by multiplication rather than addition. So what I want you to do is I want you to go ahead and find the geometric mean of 4 and 20. And once you've done that, come check your answer with me. That's all for section 8.2. Thanks, guys.